Welcome back to Mr. Scott Maths. In this video we're going to look at exact trig. For exact trig questions you will be asked to use trig functions without a calculator. This may seem like you need to memorize certain values, but we'll see in this video how we can use triangles to work answers out. We will look at how to find sine and cos of 30, 60 and 45 degrees. Now the first triangle we're going to use is an equilateral triangle, and we'll draw this equilateral triangle out. And we're going to say that this equilateral triangle has sides of 2. Of course, it's an equilateral triangle, so all of those sides are the same. Now also, because it's an equilateral triangle, we know what all of those angles are. We know that they're all 60 degrees. Now when using our trig functions, we're generally talking about right-angled triangles, but at the moment we don't have a right-angled triangle. However, we can make a right-angled triangle by splitting this equilateral triangle down the middle. So let's split it up and we see that we get this right-angled triangle, where this length is still 2. The base has been split in half, so it is now 1. This angle stays the same, it's still 60 degrees. And this angle at the top has been split in half, so it's now 30 degrees. Now, because we have a right-angled triangle, we can use Pythagoras to work out our missing length here, this height. We can do that using the square root of 2 squared, subtract 1 squared. 2 squared is 4, 1 squared is 1, 4 minus 1 is 3, so this gives us root 3. So this height of the triangle is root 3. Now, if we want to find either sine or cos of 60 degrees, let's label our sides. Our hypotenuse is always our longest side. Our opposite in this case, opposite this 60 degree angle, is our root 3. And our adjacent next to this angle is our side of length 1, our base. So if we want to find sine, we know that we're using opposite over hypotenuse. Well, if we're finding sine of 60 here, our opposite is root 3. Our hypotenuse is 2. So we end up saying that sine of 60 is root 3 over 2. We don't want to turn this into a decimal because this is exact trig, so we want to leave it in its exact form. We can do the same for cos here, where cos is the adjacent over the hypotenuse. Now the adjacent here is 1, so cos of 60 is going to be 1 over our hypotenuse, which is 2. Find that cos of 60 is a half. Now here we have the same right-angled triangle we just used, with our length of 2, base of 1, height of root 3, our angles of 60 and 30 degrees. Now we want to work with our 30 degree angle. So again, we label our sides. We've got our hypotenuse as the longest side. Our opposite is now opposite this 30 degree angle, it's the 1, and our adjacent is our root 3. So if we want to work with sine here, again, we're using the opposite over the hypotenuse, and sine of 30 degrees is going to be our opposite, which is 1, over our hypotenuse, which is 2. So we find sine of 30 is a half. Again, we can do the same thing with cos, of course, using adjacent over hypotenuse. We're finding cos of 30 degrees. Our adjacent is root 3. Our hypotenuse is 2. So we find that cos of 30 is root 3 over 2. Now we can also find sine and cos of 45 degrees using a different triangle. This time we're going to use an isosceles right-angled triangle. So if I draw my triangle out, I'm going to say that these two sides are equal and they are both 1. Then we have our third side, our hypotenuse. Here is our right angle, and our two other angles, they're equal because it's an isosceles triangle, and they're both 45 degrees to ensure that all of our angles add up to 180. Now again, we can use Pythagoras to find our hypotenuse. This time we're going to do the square root of 1 squared plus 1 squared. Well, of course, 1 squared is just 1, so this is 1 add 1. And we end up with the square root of 2. Now, it doesn't matter which of these two angles we use when it comes to labeling our sides. So let's just say we're going to use this angle here. We can label our hypotenuse. Here would be our opposite, and here would be our adjacent. So if we want to find sine of 45 degrees, again, we're using our opposite over hypotenuse like we saw before. Here, that's 1 over root 2. Now, we don't like to have an irrational number in our denominator, so we tend to try and rationalize this denominator, and we can do this by multiplying that by root 2 over root 2. This is just a fancy way of saying 1. We times by 1, nothing really happens. So on the top of this fraction, 1 times root 2 is just root 2. On the bottom, root 2 times root 2, that would be root 4, which is just 2. So sine of 45 is root 2 over 2. Now let's do the same for cos. This time we're using the adjacent over the hypotenuse, but actually we see it works out the same. The adjacent is 1, the hypotenuse is root 2, so we also get 1 over root 2. And again, if we rationalize that denominator, multiply it by root 2 over root 2. On the top, we get root 2. On the bottom, we get root 4, which is just 2. So we see that sine 45 and cos 45 work out the same. They both become root 2 over 2.